Before there were stars, before there was light, before time had any meaning at all, there was silence. Not the kind of silence you experience in an empty room, and not the peaceful silence of nature at night. This was a silence so complete that nothing existed to break it. No sound, no movement, no distance, no direction. For most of human history, we imagined the universe as something busy and alive, filled with motion, explosions, and endless activity. But in reality, the universe is mostly quiet, almost entirely quiet. If you were able to float through space right now, far away from Earth, you wouldn't hear stars burning, or planets moving, or galaxies colliding. You would hear nothing at all. Sound needs air, or at least particles, to travel. Space has almost none. This means that the most violent events in the universe, supernovae that release more energy than our sun will produce in its entire lifetime, happen in complete silence. No warning, no noise, just light spreading through darkness. And that silence is not empty. It is vast beyond comprehension. Between galaxies, there are distances so large that light itself takes millions of years to cross them. Entire civilizations could rise and fall on a planet, and their existence would never be known beyond their own galaxy. Even now, as you listen to this, there are regions of the universe whose light will never reach Earth. Not because it hasn't arrived yet, but because the universe is expanding faster than that light can travel. Those places are permanently disconnected from us. They exist, but forever beyond our reach. This realization unsettles many people, because it means that the universe does not revolve around observation. It does not care whether it is seen, measured, or understood. Most of what exists will remain unknown forever. And perhaps more unsettling is this thought: the universe does not announce itself. There was no grand sound at the beginning, no cosmic signal saying, "Everything starts now." If the Big Bang could be heard, it would not be an explosion in the way we imagine. It would be a sudden expansion of everything, happening everywhere at once. No center, no edge, no direction. Just existence unfolding silently. And in that silence, laws formed. Time began to move forward. Matter slowly gathered. Eventually, stars ignited. Galaxies took shape. And much later, life appeared on at least one small planet. But the silence never left. Even today, the universe is not filled with noise. It is filled with space. Empty, cold, indifferent space. This silence is not peaceful, and it is not hostile. It simply is. And once you truly understand how silent the universe is, it becomes clear how rare observation really is, how rare awareness is, how rare it is for anything to pause and think and wonder about the silence that surrounds everything. And now that you've begun to sense that silence, there's something even more unsettling to consider. In the next section, we'll explore places in the universe where time itself no longer behaves the way we expect. Time feels constant, a steady flow from past to future, a rhythm we trust without question. Seconds pass, minutes follow, life moves forward. But this sense of time exists only because of where you are. In most of the universe, time does not behave the way it does on Earth. In fact, there are places where time slows, stretches, and nearly stops. This is not science fiction. It is a consequence of gravity. The stronger gravity becomes, the more it distorts time itself. Near massive objects, like neutron stars or black holes, time moves more slowly compared to places far away from them. If you could stand on the surface of a neutron star, just 1 second for you would be significantly longer for someone watching from a distance. You would age more slowly. Your heartbeat would slow relative to the rest of the universe. Time for you would be different. And the closer you move toward a black hole, the more extreme this distortion becomes. At the edge of a black hole, a boundary known as the event horizon, time nearly stops. From your perspective, you would continue moving forward. Your thoughts would continue. Your body would feel normal. But to an outside observer, you would appear frozen, stretched across time, never quite crossing the boundary. This means that, in a very real sense, there are regions of the universe where the future cannot escape, where time itself collapses inward. And even without black holes, time behaves differently depending on motion. Satellites orbiting Earth experience time slightly faster than we do on the surface. Their clocks drift ahead by tiny fractions of a second every day. Without correcting for this, GPS systems would fail. Your phone would not know where you are. Your navigation would slowly become useless. This means that even now, time on Earth is not uniform. Different parts of our planet are moving through time at different rates. The difference is small, but it is real. And it raises a disturbing question. If time can slow and stretch and distort, what happens at the end? Physicists believe that as the universe continues to expand and energy spreads thinner and thinner, time itself may begin to lose meaning. In a far future scenario known as heat death, no processes remain to mark the passage of time. No stars burning, no reactions happening, no change. Without change, time becomes irrelevant. It still exists mathematically, but nothing experiences it. A universe where time continues, but nothing moves through it. And that idea challenges something deeply human, because our identity is tied to time, to memory, to anticipation, to growth and decay. Without time, there is no story, no before, no after, just existence without sequence. So when we say time is universal, what we really mean is that our experience of time is local, fragile, context-dependent, a convenience created by gravity, motion, and energy. And somewhere in the universe right now, time is flowing so differently that entire eras could pass elsewhere while almost nothing changes there. And once you realize that time itself is unstable, another unsettling thought emerges. If time can break, what happens to the light that tries to escape it? That's what we'll explore next. Light feels dependable. We use it to see, to measure distance, to understand time itself. When we look at the night sky, we are always looking into the past. The light from distant stars has been traveling for thousands, sometimes millions of years before reaching your eyes. But there is a limit to what light can do. Not because it runs out of energy, and not because it fades away, but because the universe itself is expanding. Every second, space stretches, not into anything, but away from everything else. Galaxies are not simply moving through space. The space between them is growing. And in some regions, that expansion happens faster than light can travel. This creates a boundary, a cosmic horizon. Beyond this horizon, light emitted today will never reach us. Not in 1 billion years, not in 1 trillion, never. These galaxies still exist. Stars still form there. Planets may orbit suns. Life may rise and fall. But their light is permanently cut off from Earth. It's not that we haven't waited long enough. The universe is expanding too quickly. This means that the observable universe is not the entire universe. It is only the part we are still connected to. And that connection is shrinking. Over time, more galaxies will cross this horizon. Their light will stretch, dim, and disappear. Eventually, future civilizations in our galaxy may look up at the sky and see far less than we do today. The universe will appear smaller, lonelier. Not because less exists, but because less can be seen. And there is something deeply unsettling about this. It means that knowledge has an expiration date. There are truths about the universe that are visible now, but will one day be lost forever. Even with perfect technology, perfect understanding, and unlimited time, some information will simply vanish. Light carries history. When it disappears beyond reach, that history disappears with it. This makes our moment in cosmic time unusual. We exist during an era when the universe is still revealing itself, when distant galaxies are still visible, when ancient light can still arrive. But this window is closing. Slowly, silently. And once you accept that most of the universe will never be seen, another question arises. If light cannot escape certain regions of space, what happens in places where escape is impossible? That brings us closer to one of the most extreme environments that reality allows. There are places in the universe where distance loses meaning, where direction becomes irrelevant, where the concept of escape no longer applies. These places are called black holes. Despite their name, black holes are not empty. They are regions where matter has been compressed so tightly that gravity overwhelms everything else, including light. At a certain boundary, the event horizon, the pull becomes absolute. Once something crosses this line, there is no return. No signal can escape. No information can be sent back, not even light. From the outside, a black hole appears quiet. It doesn't announce itself. It doesn't glow. It simply exists, revealed only by how it distorts its surroundings. Stars orbit it. Gas spirals inward. Time slows near its edge. And for anything falling in, reality becomes strange. From your perspective, nothing dramatic happens at the event horizon. You wouldn't feel a sudden jolt. You wouldn't hear a sound. But from far away, you would seem to slow down. Your movements would stretch. Your image would fade. You would never quite cross, frozen at the edge of time. And yet, you would continue falling. This contradiction highlights something unsettling. Black holes expose the limits of our understanding. Inside them, the known laws of physics stop working. Space and time swap roles. Cause and effect blur. The future points inward, and whatever enters is cut off from the rest of the universe forever. This raises a disturbing idea. If information cannot escape a black hole, is it truly lost? Or does it still exist, hidden beyond access? Physicists still debate this. Some believe information is preserved, encoded on the surface of the event horizon. Others believe it disappears entirely. Either possibility is unsettling, because it challenges a fundamental assumption that reality keeps records, that nothing is ever truly erased. Black holes suggest otherwise. They are places where the universe may forget. And scattered across space, there are billions of them, silent, invisible, patient, waiting at the edges of galaxies. And if black holes represent regions where information cannot escape, what happens when everything eventually moves toward that same fate? That question leads us to the far future of the universe itself. There will come a time when the universe begins to quiet down. Not suddenly, not dramatically, but gradually. Stars are not eternal. They burn fuel, and when that fuel runs out, they fade. Some collapse, some explode, some cool into dark remnants. Across billions of years, the number of shining stars will decrease. Galaxies will dim. New stars will become rare. Eventually, star formation itself will slow to a stop. This is not speculation. It is the natural outcome of a universe that keeps expanding. As space stretches, matter spreads thinner. Energy becomes harder to concentrate, and without concentrated energy, nothing new can ignite. In this far future, the universe approaches a state known as heat death. Despite the name, it is not fiery. It is cold. Heat death does not mean everything is hot. It means everything is evenly cold. No temperature differences, no energy gradients. Nothing left to power motion or change or life. Atoms remain, particles persist, but nothing happens. no reactions, no stars, no chemistry that leads anywhere. Time continues to pass, but nothing marks its passage. A second becomes indistinguishable from 1,000,000 years. In this universe, existence continues without events, and this creates a disturbing realization. The universe does not end with destruction. It ends with stillness, a slow fading into equilibrium. Everything that ever happened becomes part of a frozen past. And yet, even this may not be the final chapter, because some things last longer than stars. Much longer. When stars are gone and galaxies have faded into darkness, a few things will remain. Black holes. They are the final structures to dominate the universe. Formed from collapsed stars and galactic centers, they persist long after everything else decays. But even black holes are not truly eternal. Over unimaginably long periods of time, they slowly lose mass, not by consuming matter, but by emitting something known as Hawking radiation. It is incredibly weak, almost impossible to detect, but given enough time, it matters. A stellar black hole may take longer to evaporate than the current age of the universe multiplied by trillions. Supermassive black holes will last even longer, but eventually they too will fade, leaving behind nothing but scattered particles and vast, empty space. This means that even the darkest, most powerful objects in existence have an expiration date. And when the last black hole disappears, the universe enters its final era. No stars, no galaxies, no massive structures, only isolated particles drifting through expanding space. At this stage, the universe is unimaginably old. So old that numbers lose meaning. And yet, it continues. Not toward anything, not away from anything, just continuing. This challenges the way we think about endings, because there is no final moment, no collapse, no silence after sound, just an endless continuation without complexity, without memory, without observers. And perhaps that is the most unsettling thought of all, that the universe does not require meaning. It does not pause when nothing is left to witness it. It simply exists. And in the brief moment when stars shine, and minds arise, and questions are asked, we are living in the most unusual era of all. An era where something is still happening, and there is still time to notice it. From a distance, Earth is almost invisible, a pale point of light lost among billions of stars inside one ordinary galaxy. Our planet is not at the center, our star is not special, our galaxy is one of trillions. And yet, from this small place, we ask questions about everything. The universe does not scale to human intuition. Distances are too large, times are too long, forces are too extreme. The human brain evolved to understand seasons, days, and the space between familiar places, not cosmic expansion, not black holes, not billions of years. When we confront the true size of the universe, something uncomfortable happens. Importance begins to dissolve. Nothing about the universe suggests that humans were expected or required. Stars formed long before life existed. They will continue long after it disappears. Entire galaxies collide and merge without noticing the brief spark of civilizations inside them. And yet, despite this indifference, we observe, we measure, we remember, we reflect. In a universe that does not care, awareness still arises. That alone is unusual. From the universe's perspective, human history is a rounding error. But from our perspective, it is everything. This creates a tension. We are insignificant in scale, yet immense in experience. Our thoughts, fears, hopes, and memories exist only briefly, but they are real while they exist. The universe does not give us meaning. We create it. And perhaps that is not a weakness. Perhaps it is the rarest phenomenon of all. Because in a universe dominated by silence, even a single moment of understanding is extraordinary. And once you accept how small you are, another question becomes unavoidable. If nothing is permanent and nothing is guaranteed, why do we still look outward? Despite everything we've explored, the silence, the unreachable light, the collapse of time, the fading of stars, we continue to observe. We build instruments. We send signals. We search for patterns in the dark. Not because the universe promises answers, but because curiosity persists, even when outcomes are uncertain, even when nothing lasts. The universe does not explain itself. It offers no narrative, no reassurance, no final conclusion. And yet, here we are, listening, thinking, trying to understand. Perhaps the purpose of knowing the universe is not to master it, but to recognize our moment within it. A brief window where complexity exists, where stars still shine, where time still flows in meaningful ways, where awareness has not yet faded. One day, the universe will grow quiet again. Galaxies will disappear beyond reach. Stars will burn out. Structures will dissolve. And nothing will remain to remember what once was. But that does not erase the present. Right now, there is light to see, questions to ask, silence to notice. And maybe that is enough. You don't need to resolve the universe. You don't need to make sense of infinity. You only need to be aware that you are part of something vast, temporary, and strangely beautiful. And as you let these thoughts settle, as the universe continues its slow expansion, you can rest knowing this. For a brief moment in cosmic time, the universe became aware of itself through you. And then, quietly, it continues on.